So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 357 and in this video we continue with our user-defined conversion function. And again here in CPP reference.com you can find it in the section language, and when you go here down to the section conversion, and here you see user-defined conversion function. And here we already started a little bit with the syntax, the first part, and we watched also here the first example for that, this one and this one. And now we want to talk about the second example, this here. Okay, let's get step by step here and analyze what happens. We start here with the right side and we see here a static cast. We already learned that the word static cast means it is trying to convert one type to another type. In our case we have here the type X, the object X, which has the type X, and we are trying to convert it to a type int. And let's watch this a little bit more in detail what happens here in this part. First of all, we start here with the object X. Our target is int. So the compiler will go to the object X type, which is X, and then we jump here to the type which is here defined on top, struct X. Then the compiler tries to scan here the full body, try to find a conversion. In our case, it will find, for example, this one, which says I can convert X to an int. Then the compiler is choosing this one here. What happens then is X here is called with the operator. It is executing what happens here in the body, and the body says just return the number 7. So the whole conversion here is just returning the number 7, and this number 7 then is assigned, because this is an assignment operator, to n. So we realize the whole conversion here happens only here. It is just calling this operator here, which is similar to the example which we talked about in our last video, which is this here down. But the question is then, if this one and this one are almost the same, why we bother us and using the word static cast int and so on, instead of just writing X and assign it to m directly? And the answer is implicit copy conversion, which is the second line, is not the same like the first line here, because here we have a direct initialization, and we have talked about this also in our last video, that the static cast here looks like a copy initialization with this equal sign, but internally the compiler reads this one as a direct initialization. And this is very important because we learned also that direct initialization here can be called with the operator which has the word explicit in front, but the implicit conversion here, which is a copy initialization, are not considered with the operator when it has an explicit in front. So let's check this. So here we have our static cast int X. We go here to the struct X, we see this operator here, and direct initialization here can be called with operator explicit, but here we don't have one. That's okay, because it can be called also without the operator explicit. So the compiler can use this one, and that's why we get here the number 7 and we return it here. And if we compare this one now to the second line, and we pretend that the second line would call this one too, because it is calling this one, but let's pretend here is the word explicit, then only the first line would be able to call this one with the static cast, and the second line would be not able to call this operator here. But in the next example we will see this again. Let's see if you understand this, because the next two examples are exactly this again. So let's start here with this line step by step. We have here a pointer to an int which is called p, and we try to assign to this pointer X, but we use the word static cast, and we won't convert our X. Again, we have to check later the type and check, can we convert X to a pointer? And when we check this, then we see, yes, this line here is actually converting it to an pointer int, which we want, like here, and the cast also indicates this here as a target type. Let's repeat this part a little bit also, because this here starts with the word explicit. And before I mentioned that when you see the word explicit, it is not allowed to call it with a copy initialization or something like that. And here, this one looks like a copy initialization because we have this equal sign here. But remember, this one only looks like a copy initialization. The compiler is converting this part here to a direct initialization. We learned direct initialization can be called with the word explicit. So we can call this one here only because we use the word static cast, and it is casting the it is changing the part here to a direct initialization. Let's continue then here a little bit. This part is our conversion type ID. This part here, conversion type ID, operator int, also pointer int. And interesting is then, this is just our regular syntax for a function. Const is just that this function should be treated as const, okay? But interesting is the function body here. And why is this interesting? Because we see here the word return, but we learned here on top when we read here a little bit that this special conversion operator has no return type, and we can see this has not a return type here in front, this one has not a return type here in front like normal function. The point is here it has a return type. The text only says here on top you are not allowed to write a return type here in front like a normal function, because the conversion operator return type is included in this conversion type ID, which I just mentioned, which is this one here. And in here, the return type is this part. So we see we have indeed a return type, but the only difference is it is not written here in front like a normal function. It is written here in the function, in front of the function parenthesis. That's the real difference. And now the return null pointer makes also sense because we are returning to this one here. And when we go back now to our function, to our example here, we see we are returning here the null pointer, and a null pointer can be assigned or initialized here our p pointer. And let's jump here to the next line, which is this one, and you can see this one and this one look similar like this one here on top. The only difference is now not here. The only difference is now here in the struct. We have now the word explicit here and no possibility to call it. So let's check this one here again. We're trying to create a pointer called q. It's a pointer to an int again. We use the object x from here, but instead of using the static cast, which was converting the whole part here to a direct initialization, this part we don't have now. We have here a copy initialization, and we learned a copy initialization is only allowed to call operators without the word explicit. Then the compiler checks, okay, I have only one option because my target is the pointer int, and the pointer int operator is defined here, the only option, but with the word explicit. So I can't call even this one, and the result is error, no implicit conversion. And when we compare now this line here with this line here, the final question is why we are doing this. And one answer is it is intentionally a program design so that the programmer know in this example, if you want convert x to a pointer int, you have to write the static cast, because then you are aware that x will be converted to a int pointer, because if you are writing it not like in this example, you don't know really what happens here when you just watch it. Okay, I think that's enough for this video. Again, in the next video we continue with the next example, which is also a little bit complicated, but if you have any questions like all time, write in the comment section. See you in the next video. Bye and good luck.